Hello viewers, welcome once again to my channel, Ojuk's Online Maths Class. Remember, in this channel, secondary school mathematics, physics and further mathematics scheme of work are being covered serially. This will go a long way in helping students to cover the scheme of works given to them in their various schools. So I urge every teachers, parents to do well to recommend this channel to their kids so as to ease learning. Also, at the end of each class, drills will be given. So do well to attend the drills and drop your solution at the comment section for assessment and markings. Okay, in our previous class, we looked at the first topic in the SS1 scheme of work in mathematics, which is the number-based system. We discussed the concept of number base. We also looked at how to convert a number that is in base 10 to every other base, which involves just repeated division. So today we'll be looking at another phase of number base, which is conversion of a given base to base 10. We want to look at how to convert a number that is in another base to base 10. It is very simple. How do you do this? If you want to convert a number which is in another base to base 10, it simply involves method of expansion in the powers of the old base. So if you want to convert a number from another base to base 10, it simply involves what? Expansion with the powers of the old base. How do you do this? Okay, let us observe some examples. Now, we want to look at conversion of 321 or 321 in base 5 to base 10. This is a number in another base. We want to really look at how to convert 321, a number in base 5 to base 10. Remember what I said earlier, that if you want to convert a number from one base to base 10 or from another base to base 10, it simply involves method of expansion with the powers of the old base. Okay, let us now solve this. 3, 2, 1, a number in base 5 to base 10. How do we start? Now, first thing we have to do here is to assign powers to these values. Starting from here, 1, we have our 0. Then second one bears the 1. Then third, we have the 2. Now we'll start our expansion. See how we're going to do our expansion? Very simple and easy. First of all, we'll multiply the first digit here with our base. Then we'll raise it to the power as we have here. So we'll have the first digit there, which is 3, times the base, which is 2, raise it to the power of what? 2. As you can see, 3 is having the power of 2. So we'll have raised to power 2 plus, then the second number is 2. We'll have 2 times the base, which is 5. Raise it to the power of what? 1. You can see there that 2 is having the power of 1. Then plus 1 times 5, raise it to the power of what? Of 0. We'll have raised to power 0. Now, when we keep on solving this, we'll have this to be equals to 3 times 2 raised to power 2 will automatically give us 4, plus 2 times 5 raised to power 1 gives 5, plus 1 times 5 raised to power 0. In mathematics, we all know that any number or any value raised to the power of 0 is 1. So we have 1 times 1. So if we keep on processing this, 3 times 4, we are having 12, plus 2 times 5, we'll have 10, then plus 1 times 1 will give us 1. So if we solve further, 12 plus 10 will have 22, then 22 plus 1 will give us 23. Remember, we just converted to base 10. So converting 3 to 1 base 5 to base 10 gives 23 base 10. Okay, let us observe some other examples. Let us look at Number 2, convert 422, a number in base 5, to denary. Remember, another name for base 10 is the denary system. How do you convert 422 base 5 to denary? As usual, it involves what? Method of expansion with respect to the powers of the old base. Now let's do the same thing as you have here. We have 422, a number in base 5. We are asked to convert to base 10. How do we do this? We assign our powers as usual. From here, we have our first one 0, 1, 2. Now we'll kick off with our expansion. Remember, 4 will multiply, or the first number multiplies the base, or each of the numbers will multiply the base, then we'll raise it to what? To their respective what? Powers. So first of all, we have 4 times our base is what? 5. We have 4 times 5 raised to the power of what? 2, plus 2 times 5 raised to the power of 1, plus 2 times 5 raised to the power of 0. Now, if we are to expand this, we have this will give us 4 times 5 raised to the power 2 gives 25, plus 2 times 5 raised to the power of 1 will give us 1, will give us 5, plus 2 times, remember, 5 raised to the power 0, anything raised to the power 0 in mathematics will automatically give us what? 1. So we are having 2, 5 raised to the power 2 will automatically give us 1. So we have 2 times 1. So if we solve further, 4 times 25, we're having 100. So this is 100 plus 2 times 5, we'll have 10, plus 2 times 1, automatically we'll have 2. If we add 100 plus 10, we're having 110. Then 110 plus 2, we're having 112. That is 102 base 10. Okay, having known this, most times you will be given a number in decimal. You might be given a number in decimal and be asked to convert such number to base 10. You can be given a decimal number and you will be asked to convert that decimal number to a number in base 10. How do we do this? If you are given a decimal number to convert to base 10, let us observe. Let's assume you have number 3. Convert 110.01 base 2 to base 10. To base 10. Now let us observe this. This is a decimal number. We are asked to convert this decimal number to a number in base 10. As you can see, the decimal number is in base 2. How then do you convert a decimal number to base 10? It is also very simple. You assign your powers, then you do your expansion. Now, how do we then assign our powers in this case, or in terms of this decimal number? Now look up here. To solve this, we'll have 110.01 base 2 to be converted to base 10. Now we have a unique way of assigning powers to this kind of value that is in decimal. Automatically, if you observe this decimal number, we'll have the whole number part in this decimal number and as well the decimal part. Just as usual, we are going to assign our powers usually as regards to the whole number part, which is in the whole number part, we assign our values just as we used to do 0, 1, and 2. Then for the decimal part, the first digit or the first decimal number in this value bears the power of -1. followed by what? The second one, which is the power of what? Minus 2. The same goes if the decimal part keeps extending. So now, let us expand this. This gives, as usual, 1 will multiply the base, which is 1 times 2, which is the base, raised to the power of 2, plus 1 times the base, which is 2, raised to the power of 1, plus 0 times the base, which is 2, raised to the power of 0, plus, now we'll come over to the decimal part. 0 times 2 raised to the power of minus 1, plus 1 times 2 raised to the power of what? Minus 2. So having done this, we'll keep on with our expansion. We have here 1 times 2 raised to the power 2 will give us 4, plus 1 times 2 raised to the power 1, we're having 2, plus 0 times 2 raised to the power 0. Anything raised to the power 0, as usual, gives 1. So we have 2 raised to the power 0 equals to 1, plus 0 times 2 raised to the power minus 1. Automatically, 0 times anything gives 0. We have 0 plus 1 times 2 raised to the power minus 2. In indices, under negative index law, automatically this negative number renders this as a reciprocal. So in return, we are having 1 over 2 raised to the power 2. If we keep on solving, this will automatically give us 1 times 4, we're having 4 plus 1 times 2, we're having 2, plus 0 times 1, we're having 0, plus then 0, plus 1 over 4. If we solve further, 4 plus 2, we're having 8. 8 plus 0, we're having 8, plus 1 over 4. This is over 1. So when we have a fraction, in this case, how do we solve this? Automatically, we'll have to look for the LCM. Now, when we solve for the LCM of the denominator, we're having the LCM of the denominator as 4. We'll bring down 4. 1 into 4, or 1 divides 4, we're having 4. 4 times 8 will automatically give us 32, plus 4 into 4, we are having 1. 1 times 1 will give us 1. So this gives 32 plus 1, we are having 33. So we're having the result is 33 over 4. Okay, we have 33 over 4 as our result, which is the result of 110.01 base 2 to base 10. So having 33 over 4 to base 10. Okay, let us try this, or you can try this. You can try this. Remember to drop your answers or your solutions at the comment section. You can try this. Number 1, convert 321, a number in base 5, to denary. Number 2, convert 411, a number in base 8, to base 10. Again, convert 111.101, a number in base 2, to base 10. So do well to attempt the drill and drop your solution at the comment section for assessment. Thank you for watching. Remember, do not forget to subscribe to my YouTube channel at Ojuk's Online Maths Class. Also, you can follow me on Facebook, also at Ojuk's Online Maths Class. So together we'll eliminate mathematics phobia. Have a nice day, everyone.